Hello again, Algebra 2 students. We are back in our complex number syllabus, and we are on Tier 2, Lesson 4, Graphing Complex Numbers with Quadratics. Let's check off our booklet, and here we are. Let's start by filling out this box over here. We want to say that the absolute value of a complex number is the distance from the origin in the complex number plane, with the origin being right here. This concept is derived from the Pythagorean theorem. If you remember the Pythagorean theorem, when you have a right triangle, you have a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So to find this length, called the hypotenuse, which is c, you would just take the square root of a squared plus b squared. Let's come over here to the graph and explore this a little more in detail. So if you remember from Tier 1, we graph real numbers on the x-axis, and we graph the imaginary numbers on the y-axis. Okay, so to graph this complex number here, what we're going to do, the 3 minus 2i, we're going to come on the x-axis, which is the real axis. We're going to come over 3, just like we did in Tier 1, and then down 2 units on the imaginary axis, just like we did in Tier 1, and our point's going to go about right here. Well, that forms a right triangle with the x-axis right here, so we can find the hypotenuse, which is the distance from the origin, just by saying, okay, we got 3 units on that axis and 2 units on this axis. So we go the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. So that is actually our distance from the origin for that complex number if plotted. And then for this complex number, if we plot it, we would go back 4 on the real axis and then up 3 on the imaginary axis. That would put our point about right there. And again, we're making a right triangle with the x-axis. That is 3 units up and 4 units back. So then we would have the square root to find the hypotenuse here. We would have the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which equals 5. So the distance from the origin for the second complex number is 5.